Thank you for watching. This is Mr. Anderson from Kellogg Community College. We are looking at part 2 of our Chapter 2, Section 3 trigonometry video here. We're looking at some sine and cosine values, and we're going to derive the exact value of the 4 remaining trigonometric functions. Pretty straightforward. The only difference between this and maybe working with the unit circle is that these will actually be positive and negative, so we got to keep that in mind when we start looking at tangent and cotangents. So here we are with sine and cosine. We can easily find the cosecant and the secant by doing the inverses of these. So with everything ready to roll here, my cosecant is going to be 5/4, and the secant is going to be negative 5/3. The tangent is going to be y over x, so it's going to be 4/5 times negative 5/3. Because instead of going y divided by x, I'm going to go y times the reciprocal here. So the 5's simplify to negative 4/3. And the cotangent's very simple because you can just invert your tangent to get your value there. The cosecant here is going to be, we're going to flip the sign on its head, so this is going to be negative 5 over square root of 5. Of course, we're going to rationalize the denominator, square root of 5 over 5. The numerator then becomes negative 5 square roots of 5 over 5, so we simplify that. The cosecant is negative square roots of 5. The secant is going to be the flip of the cosine. So this is going to be 5 over, negative 2 times the square root of 5. Rationalizing the numerator by multiplying the top and bottom by square root of 5 over square root of 5, we get 5 square root of 5 over negative 10. And you can see that we can simplify that out because that's going to be positive 1/2, or sorry, negative 1/2 times square root of 5. So negative square root of 5 over 2 is our simplified version of this cosine turned into secant. Now our tangent is going to be taking our sine and dividing it by cosine. 2 negatives make a positive. That's going to be stated, and I will show you the algebra. I'm going to flip this on its head, so this is multiplied by negative 5 over 2 square roots of 5. The 5 simplify. These simplify as well, so this leaves me with a positive 1/2, because the only thing I have left is 1 over 2. And then the cotangent's just that flipped on its head, which in this case is 2. So down here, this is our this is a very easy one to do. We've seen this before. If we've done this enough times to know that flipping this on its head and rationalizing the denominator is 2 square root of 3 over 3, and then this is going to be 2. The tangent is going to be this divided by this, which the 2 flipped on its head, the 2's will simplify, square root of 3, and the cotangent is going to be 1 over square root of 3, or square root of 3 over 3. This is one of these ones that we've memorized at this stage of the game, so it's pretty fast and pretty straightforward. This next section, though, I will try to teach it from the geometric standpoint, because what we're going to do is try to find the exact value of trigonometric functions of theta given one of the 6 trigonometric functions. So we're going to be given a function, in this case cosine. We're also going to be given the quadrant. And I strongly recommend that we draw a triangle that would represent that. So if we're in the 4th quadrant, we are on positive on the x and negative on the y. Our right triangle, if we were to build it, would look like so. Now, from theta, we know the cosine is 3 over 5. Cosine, the definition from SOHCAHTOA that we've used as our shortcut here, is going to be adjacent over hypotenuse. Now, adjacent over hypotenuse gives us some values that we can use. We can use the Pythagorean theorem to figure out what our missing side is right here. Pythagorean theorem states a squared plus b squared equals c squared. And what we have here is we have our a and we have our c. So we have 3 squared, or 9, plus b squared equals c squared, or 25. Subtract the 9 from both sides. B squared is equal to 16. Take the square root. B is equal to plus or minus 4. Now, which one I use is in relative to what quadrant I'm in. And since in quadrant 4, the sign values, or the x values, are negative, I'm going to put down there a negative 4. This is very helpful to me when I actually do my problem. I can actually use this as a big help. The secant is, and I labeled these parts A and B, so we can talk about these if we needed to in class. The secant is the reciprocal of this. So this is going to be 5/3. That's pretty straightforward here. The sine is going to be the opposite over hypotenuse, so negative 4/5. Now you can see why the geometry of the triangle is so important, because you can use the definition of sine, cosine, and tangent and their inverses to get your answer. This is 5/4. Tangent is going to be opposite over adjacent. So this is going to be negative 4 over 3. And cotangent is adjacent over opposite, or x over y. So this is going to be our negative 3/4. So you might actually look back at this triangle and you know, some of you said, well, why did you use this as your, x? And I used that as my missing value, but in the future I'm going to probably call that y, because that is my missing height from inside the circle. So we solved for y up here to find it was 4, and after we took the square root, we evaluated should it be positive or negative. So now we are at sine theta of negative 5/13 in the third quadrant. Now in the third quadrant, our triangle is going to look like this, because this is where our x's and y's are both negative. We are told that the sine is negative 5/13. Now our hypotenuse is never going to be negative, because we're going to consider that like a distance. This is going to keep things straight for us as we do the stuff on the unit circle. But in this case, we have the sine, which is our opposite over hypotenuse. We're going to consider that a negative 5. Now, what we're missing here is we're missing this distance x, and it really is our x distance there. So we're going to use our Pythagorean theorem, our a squared plus b squared equals c squared, and we're going to figure out this value x. It's the leg of the triangle there. So we're going to plug in our 5 squared, or 25, and notice that the negative 5 when squared is positive. This is going to be our x squared, which is the other leg of the triangle, and this is going to be 13, which is 169. Subtracting the 25 from both sides, our x squared is equal to 144. Taking the square root, x is either positive or negative 12, and in this case, based in the third quadrant, we're going to be negative 12. So our cosecant is going to be the inverse of this, because the definition of cosecant is the inverse of sine. Then what we're going to do is we're going to talk about the cosine right there. The cosine is going to be our adjacent over hypotenuse, because that's the definition of cosine. So adjacent over hypotenuse is going to be negative 12/13. And then we're going to have cosine and secant. Do the reciprocal of that, so 13 over 12. Tangent. The tangent value right there is going to be our opposite over adjacent. Now see, the opposite over adjacent is negative 5. Let's see, negative 5 over negative 12, which can be simplified to 5/12. And then our cotangent is going to be the reciprocal of that, which is 12 over 5. Okay, so let's move on to problem number 18. Now you'll notice they're being just a little coy with us about the actual place on the unit circle. But if you're between 270 degrees and you're between 360 degrees, you're in the fourth quadrant. So your triangle is going to be written something a little like this. There's your fourth quadrant triangle right there. We know cosine. The definition of cosine is going to be adjacent over hypotenuse. So the adjacent angle to theta is 4, and our hypotenuse is 5. Notice they're both positive, because our x is positive and our hypotenuse is positive distance. So therefore our y value is what we need to find here. So using the Pythagorean theorem a squared plus b squared equals c squared. We have our hypotenuse, which is 25, because it's 5 squared. We have our 4 squared, which is 16, and our missing leg, which is y. Subtract the 16 from both sides. Y squared is equal to 9, which means y is equal to plus or minus 3 based on the quadrant we're in, and that will mean that the y is equal to negative 3. So we can get our secant by doing the reciprocal here, and we can do our sine here by doing, from theta, we will do the opposite over hypotenuse, and it's negative. Make sure that the cosecant is the reciprocal of that. Tangent is going to be opposite over adjacent, so negative 3 over 4, and then flip this on its head, negative 4 over 3. All right. Moving on to problem 19. Well, where is that place in the unit circle? Well, we're between pi, and we're between 3 pi over 2, so this must be between 180 degrees and 270 degrees, so that puts us again into the third quadrant. You're going to see a lot of these examples like to stay away from the first quadrant where everything's nice and positive. So let's go to that third quadrant place, and let's make our triangle. This is the triangle in the third quadrant. Here's our theta of our angle, and we're going to go to take a look at negative 2/3. So this means my hypotenuse is 3, and since the sine is opposite over hypotenuse, so there's negative 2 over 3, which means we have to find our value of x, which will be negative once we take the square root. So let's go find it. What we will do is we'll use our Pythagorean theorem, a squared plus b squared equals c squared. We will plug in our leg, which is negative 2 quantity squared 4, plus our x squared, we don't know the other leg, and 3 squared, which is 9. Subtract the 4 from both sides, x squared is equal to 5. So if I take the square root of both sides, x is going to be equal to positive or negative square root of 5. So x is the distance of negative square root of 5. So the cosecant, again, we're just going to flip this on its head, the nice reciprocal there. The cosine is going to be the adjacent, or over the hypotenuse. And there we go. There's adjacent over hypotenuse. Then what we have for secant is this flipped, but make sure you rationalize the denominator by multiplying top and bottom by square root of 5. So we have negative 3 square root of 5 over 5. Tangent. The tangent is going to be opposite over adjacent. So negative 2 over negative square root of 5, which is 2 over square root of 5, because negative divided by negative is positive. Then we rationalize the denominator by multiplying top and bottom by square root of 5. So we get 2 square roots of 5 over 5. To do cotangent, it's going to be the other way around. We got negative square root of 5 over negative 2. Now you can flip this on its head, but you can flip the earlier one on its head, and you get negative square root of 5 over negative 2, which again turns positive because 2 negatives make a positive. Things get a little trickier here when we go to our last 4 problems in this video. The reason why they get tricky is because they just told us that the tangent is going to be greater than 0. Now what's tough about that is if the tangent is greater than 0, that means that you have a y over x that's positive. So your either choices are the y over x they're both positive, or you can have a situation where your y over x's are both negative. So this is going to be either the first quadrant or the third quadrant. So we have to look at our cosine and see that, well, since our cosine is a negative number, then there has to be a negative value over the hypotenuse, so therefore this is not in the first quadrant, it's in the third quadrant. So here we go. I'm making another triangle, the third quadrant. Now, what's really tricky about this is you'll notice that this here is the cosine of a negative 1, 4, which means that our hypotenuse is 4, and this is going to be negative 1. So what we have to do now is figure out what our missing leg is, which is going to be our negative y distance. It's negative because it's going to be in the third quadrant. So use our quadratic formula again, a squared plus b squared equals c squared. I'm sorry, Pythagorean theorem again, and we will plug into a the negative 1, so that's going to be positive 1. B is going to be our y value, and c is going to be our 16, so 4 squared. Subtract the 1, y squared is equal to 15. So we take the square root, y is equal to plus or minus the square root of 15, which can't be broken down any further. There's no way to simplify this because it can't be it isn't divisible by 4 or by 9. So y is the square root of 15. Since y is the square root of 15, now what we have is we can compute our values here. The secant is negative 4. The sine is going to be our opposite over hypotenuse, so negative, whoops, forgot my negative there, negative square root of 15 over 4. And our cosecant is going to be 4 over the negative square root of 15. Now, I'm going to multiply top and bottom by square root of 15, so I got negative 4 square roots of 15 over 15. Tangent. The tangent is going to be opposite over adjacent, so that is going to be negative square root of 15 over negative 1, which is just square root of 15. And our cotangent is going to be 1 over square root of 15, or if I rationalize the denominator, square root of 15 over 15. So, in problem 21, 3 problems to go here for this video, we have a cotangent that is less than 0, or negative, which means that I have to have either a negative x over y, or I have to have a negative or positive x over negative y. These puts me in one of two. It puts me in quadrant 2 or quadrant 4. So let's take a look at what I have here. I have the cosecant is 3, which means that my 1 over y is going to be 3. Well, that means that this has to be the place I'm at. I have to be in the negative x, positive y. So that means I'm in the second quadrant. This is the first problem in the second quadrant. So this is the orientation of the triangle created in the second quadrant with my theta. So I can easily do this answer, but now I'm going to take a look at cosine. Now, from my sine of theta, sine is opposite over hypotenuse, and I can figure now what my x value is. And my x value is going to be negative because I'm in the second quadrant. So here we go again with a squared plus b squared equals c squared. What I have here is I have 1 squared plus our x squared is equal to our 3 squared, which is 9. Subtract by both sides, our x squared is equal to 8, so x is equal to the square root of plus or minus the square root of 8. But hold on here, folks. We can't actually just say that x is equal to negative square root of 8, because square root of 8 is, you can actually break that down into the square root of 4 and the square root of 2, or 2 square roots of 2. So x is equal to negative 2 square roots of 2, which is important because this definitely puts into play what we have to do here for our cosine and secant. Our cosine is negative 2 square roots of 2 over 3. And this on its head would be 3 over negative 2 square roots of 2, but I'll go through and rationalize, multiply top and bottom by square root of 2. So the answer is negative 3 square roots of 2 over 4. And that's because the square root of 2 and square root of 2 make 2, times 2 is 4. I move my negative up to the top because it seems to be pretty easy there. Alright, so my tangent is 1 over the negative 2 square roots of 2. Now if I rationalize that denominator, I'll get square root of 2 on top and bottom, so this problem ends up as a negative, sorry that kind of runs into this one here, let me scribble it out just so you can see where it's at. If I rationalize top and bottom by square root of 2 over square root of 2, I get an answer of the negative square root of 2 over 2 times 2, which is 4. Now I can flip that on its head, but obviously it'd be easier just to flip this on its head right there, because if we go x over y, we'd have negative 2 square roots of 2 divided by 1. So there's my cotangent of that angle. Alright, with 2 to go, 2 of the tougher problems here. Alright, and I'm sorry, we're going to do one and then we'll scroll to the other since they break the page. Cosine of theta is less than 0. Alright, so what this tells me that my x value is less than 0, so I'm either in the second quadrant or third quadrant. because that's where my x's are negative. Notice that my cotangent, or my x over y, has to be positive, a positive 4/3. So that means that my y has to be negative. Congratulations, I'm in the third quadrant, and my triangle is going to look like this. Now, since the cotangent is x over y, this would mean that my x would be -3 and my y would be -4. And now we're going to find our value of x here, or not x in this case. In this case, it's going to be our hypotenuse. And our hypotenuse is typically the C part of our right triangle from our reference point theta there. So what this is going to give me, it's going to give me my a squared plus b squared equals c squared, and it's going to be interesting because I know the legs here. This is going to be -3 squared, which is 9, and -4 squared, which is 16, equals c squared. 25 is equal to c squared. C is equal to plus or minus 5, but in this case, since it's the hypotenuse, it's going to be a 5. So the tangent is going to be -4 over -3 over -4. So two negatives make a positive. The sine is going to be, and luckily there are no roots in this problem, so we can kind of quickly go through here and do these fractions. Sine is going to be -4/5. Cosecant is going to be -5/4. Cosine is going to be, let's see here. It's going to be adjacent over hypotenuse, -3/5, and secant is going to be the reciprocal of that, which is going to be -5/3. Okay, so for our final problem of this worksheet, we're going to get to tangent being greater than 0. And with tangent being greater than 0, what we're going to see is we're going to see that my y over x both have to be positive. My y over x both have to be positive, so I'm either in the first quadrant or I'm in the third quadrant because I can have -y over -x. Now, since I have my secant of -2, my cosine is going to be -1/2. And that's -1/2 because this is just the reciprocal of this. So since I have a negative here for my hypotenuse and my adjacent side, I must be in the third quadrant. So another third quadrant problem. Did you see that any of these were in the first quadrant? Not a one of them. So what we'll have here, since my cosine is going to be my adjacent, so -1, over my hypotenuse, which is 2, I get to play the Pythagorean theorem game again to figure out my missing distance, in this case my -y distance. So let's go do that. Let's go take my a squared plus b squared equals c squared. I know only one of my legs, which is 1, plus this in case my y squared equals c, which is 2 squared or 4. Subtract 1 from both sides, my y squared is equal to 3, so therefore my y is equal to plus or minus the square root of 3. So in this case my y is negative square roots of 3. So going from my sine, this is negative square root of 3 over 2. Going from my cosecant, which is going to be 2 over negative square roots of 3, or if I rationalize the denominator there, this is going to give me 2 square roots of 3 over 3. My tangent is going to be my negative square root of 3 over -1, which is square root of 3. Two negatives make a positive, and this is going to be 1 over square root of 3, which is square root of 3 over 3. If I rationalize that, these should start to look familiar from the unit circle that you memorized. Well, thank you for watching.